let's just say we're given a problem like this. 3x minus 1/2 minus 1 over x equals 0. This seems like a lot of things here. And remember that there are two methods. One is that you're going to create the same denominator for all of these problems, or all of these different things in your equation. Or what you could do is you can get rid of your denominators entirely. Okay. So my preferred method is definitely to eliminate all the denominators. So what I like to do is I like to go and look at each one of my denominators, and I like to multiply every term by the denominator. So what I mean is that here I see a 2 on the bottom, and I also see an x on the bottom. So my initial thought is I'm going to eliminate the denominators by just increasing everything by the same amount, right? I'm multiplying everything by the same amount. So in this case, I think, okay, there's a 2 on the bottom, there's an x on the bottom, so I'm going to multiply everything by 2x. The reason is there's a 2 on the bottom and there's an x on the bottom, so by multiplying everything by 2 and then everything by x, I'm getting rid of all my denominators. So the first term, it's going to be 3x times 2x, which is equal to 6x squared. This second thing, the 2's are going to cancel out, and it's just going to be negative x. And then this 2x is going to times this negative 1 over x, which equals negative 2, and that equals 0. That equals 0. Okay, so at this point, you could just, go ahead and either factor, or you can use a quadratic formula if you feel like you cannot factor. This one is actually factorable, so again, I know that some of these are a little more difficult. So like this one, what you would do is you'd factor, so you would do the x method. Again, you could always use quadratic. Quadratic always works. In this one, you could do a times c, which is 6 times negative 2, which is negative 12. And then here you do the b, which is negative 1. You want to think about what two numbers when multiplied equals the top, what two numbers when multiplied equals or added together equals the bottom. The numbers are really close together. One of them is negative, one is positive. And the number you're probably thinking about is negative 4 and positive 3. Right. Negative 4 times 3 is equal to negative 12. When added together equals negative 1. But just as a reminder, if there is a number in front of x squared that's not equal to 1, then we have to go ahead and use our next method, which is the box. And what we want to do is we want to write the 6x squared in the top left. We want to write the negative 2 right here. And we're going to write these two numbers on the side. So we have negative 4x and we have 3x. So you want to think about what two numbers when multiplied equals negative 2. What times what? What times x equals negative 4. What times x equals 3x. And again, one of these is going to be either 6 or 2 and 3. So we can start off simply. This one looks like it's easier to start off with the numbers that multiply equals negative 2. This one can't be a 2 because 2 times something does not equal 3x. So likely this is going to be positive 1 because something times 1 is equal to, positive 3x. And so this one would be negative 2. So I can already reason that this one's negative because I have a negative 4x here. I can reason that this one is probably 1. Because I can't have 2 here, because 2 times something can't equal 3x. So then likely it's 1 and negative 2 equals, times each other equals negative 2. Well, 1 times x does not equal 3x, so that means this one must be 3x. Right? 3x times 1 equals 3x. And this one, what times what? What times negative 2 equals negative 4x? Well, this one probably needs another 2 there. So now that I have the factors, I can just factor 2x plus 1 times 3x minus 2 is equal to 0. And then I do 2x plus 1 equals 0, or 3x minus 2 equals 0. I'm going to do minus 1, 2x equals negative 1 divided by 2, x equals negative 1/2, plus 2, 3x is equal to 2 divided by 3 on both sides, x equals 2/3. Okay, let's just say that this method is too hard because you're like, wow, that is a lot of steps. What you could do is you honestly could just memorize the quadratic formula. Again, the quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And all you really do is you just fill in a, b, and c, and then you just solve. Okay, and you should get the same answer. X equals negative 1/2, x equals 2/3. So I highly recommend, if this does not come a little clear to you, you just use that method. Okay, so again, for these ones, you just want to get rid of the denominators by multiplying everything. Actually, on the test, I might just give you easier problems. These ones are a little more complex, so I might just have one of these. If you need to factor. Okay, I'm going to cover something from the first set that we did. So you can see here that we have a problem that says Bill can finish a report in 2 hours and Maria can finish the same report in 4 hours. How long will it take them to finish the report if they work together? So this is what we call a work problem. Again, this is if you ever want to do a job together, you got some contractors, you want to think about how many people to hire. This is likely what you would use to just kind of figure out how many people do you actually need on the job. Okay, so Bill can finish a report in 2 hours. Again, for this, we would just say, well, it takes Bill, for one job, it takes him 2 hours. That's it, right? It takes Bill, for one job, it takes him 2 hours. Well, they're asking us, well, Maria, it takes her, for that same job, that same report, it takes her 4 hours. Okay, so for that one job, it takes her 4 hours. The reason why we have 1/4 is that every hour she completes technically 1/4 of that job, right? Completes 1/4 of that job. Well, it's asking us what happens, how long will it take if they work on a report together? Well, we know that Bill can finish it in 1 divided by 2, and we know that they're working together, so we're going to add their reports together, and we're thinking, well, to finish one report, we're trying to figure that out. It's going to equal X amount of time, right? It's going to be some set amount of time. We don't know what it is. So again, one job takes Bill 2 hours. One job takes Maria 4 hours. And when they work together, that's why we add them together. That equals one job divided by however much time it takes, right? So just like the problem before, what we're going to do is I like to get rid of the denominators. So I want you to look at all the denominators here, and I want you to think about what number would I multiply everything by, and is there any variable I would multiply everything by. So if I look here, I can see, okay, 2, maybe I'll multiply everything by 2 to get rid of that denominator, but you can see that 4 also contains 2 as a multiple, so I can just multiply everything by 4. The second thing is that there's also an x on the bottom, so I'm just going to multiply everything by x. So there is a 4 on the bottom, and remember 2 is a part of 4, so I can just multiply by 4. It's going to get rid of the 2 also. So I'm multiplying the 1/2 by 4x, I'm going to multiply 1/4 by 4x, and I'm going to multiply 1 divided by x by 4x. Okay, I'm going to distribute to every single term. So 1/2 of 4x is 2x, 1/4 of 4x is equal to x, and then 4x divided by x is equal to 4. Now I just add it up together. I get 3x is equal to 4. I divide both sides by 3, and I get x is equal to 4/3. Well, what does it mean when you have 4/3 of an hour? Well, 1 hour is 3/3, right? But 4/3, what's 1/3? So this is equal to 1 and 1/3. So what is 1/3 of an hour? Well, 1/3 of an hour is 20 minutes, right? So 20 minutes plus 20 minutes plus 20 minutes equals an hour. So this would just mean it would take them 1 hour and 20 minutes. And that's it. You're done. Okay? You're done. So just make sure you know how to convert this. Make sure you know what you're talking about here for the report. Okay. So this is a very easy way to figure out work problems, rate problems. They're basically the same thing. Okay. Any questions on this? Okay, so I actually think that the rate problems are probably the hardest, or the speed, but we'll talk about this. Setting up the problem is probably 90% of the battle. Solving it is probably 10% of the battle, I'd say. Okay, so very same idea here. It says that it takes Leah 7 more hours to, typo here, paint a kitchen that it takes Hank to complete the same job. Together they can complete the same job in 12 hours. How long does it take Hank to complete the job if he works alone? So, what we know is that it takes Leah, for one job, it takes her 7 more hours than Hank, right? 7 more hours. So we know that she completes the job in the same amount of time as Hank, but she takes 7 more hours. So she takes the same amount of hours as Hank plus 7 hours, right? If Hank takes 1 hour, she takes 8 hours. If Hank takes 2 hours, she takes 9 hours. We know that they can work together, so, well, Hank moves at Hank's speed, which is just h. For one job, it takes them h amount of hours, right? Well, if we add their rates together and they work on a job together, it takes them, for one job, they complete the same job in 12 hours. So that was probably 90% of the question right there, is just trying to set it up. And now we can go ahead and solve. Okay, so for this type of problem, again, at least I like to get rid of all the denominators. So you want to think about, what can I multiply everything by to get rid of all the denominators, right? So you should look at your denominators and think, okay, how do I get rid of that? How do I get rid of that? And how do I get rid of that? And so first, I can multiply everything by the same thing, every single term. So the first thing I want to get rid of is my first denominator, h plus 7. So to get rid of that, I multiply everything by h plus 7. To get rid of the h, you can't just add 7 to the h because that's not the same thing. So I have to multiply everything by h. The next thing I see is the 12. Well, I don't want to deal with fractions here, so I'm going to multiply everything by 12. And so quite simply, all you do to get rid of all the denominators is multiply everything by every single denominator. Okay. So I'm going to look at my first one. I'm going to say I'm going to do 1 over h plus 7 times h plus 7 times h times 12. Well, the h plus 7's cancel out, so I'm left with 12 times h. This 1 over h times all three things, again, I am left with, the h's cancel out, so I'm left with plus 12 times h plus 7. And this last part, the 12's cancel out, and so I'm left with h times h plus 7. So now I can just add everything up together. I have 12h plus 12h. And this, just remember to distribute. So 12h, that's 12h. 12 times 7 is equal to 84 equals h squared plus 7h. And now I can move everything to one side because I see there's a h squared and there's an h. That means I have to factor. So I'm going to minus everything by 24h. Minus everything by 84, minus everything by 24h, minus everything by 84. And I'm left with 0 is equal to h squared minus 17h minus 84. So now the biggest job here is just to factor. I'm just going to do the x method right here, put the negative 84 on top, negative 17 on the bottom. I want to think about what two things when multiplied equals the top, when added together equals the bottom. This one's probably a little more difficult. So this one, for me even, I need to think about it. A big clue here is that one number is positive, one number is negative. The bigger number is negative, the smaller one is positive. So we can think about things like, 84 and 1 are too far away. We can do 2 and 42. That's too far away. We have 3 and 28. That's still too far away. We have 4 and 21. Let's see here. 21 minus 4 is not 17. And when you multiply it equals 84, we know it's 21 and 4. And we know the negative one is bigger, so it's negative 21 and positive 4. Well, that means 0 is equal to h plus 4, h minus 21. So we factored this correctly. And then we would solve for it. So we do h plus 4 is equal to 0, or h minus 21 is equal to 0. And we would get minus 4 on both sides. H is equal to negative 4 and plus 21 on both sides. H is equal to 21. And so now you want to think about this. Can Hank take negative 4 hours to complete a job? That's probably impossible unless he's can travel in time. Can H equal 21? Does it possibly take Hank 21 hours to complete a job? That makes a lot more sense. So it takes Hank 21 hours and it takes Leah 28 hours. And there we have our solution. So it takes Hank 21 hours. So we can cross this one out. Okay, so this is why when you solve for things, you can get two solutions, but one of them is extraneous because it doesn't make practical sense. You can't take negative 4 hours to complete a job. Even though there's a possible solution, it just doesn't make sense. Any questions on this one? So again, this one, what we did is we try to get rid of all the denominators. We multiplied everything by the denominators, and then we solved. Okay. Let's talk about these last two problems. These ones are the other type of problems that we'll have on the test. So this one says, a speedboat can travel 32 miles per hour in still water. It travels 150 miles upstream against the current and returns to the starting location. The total time of the trip is 10 hours. What is the speed of the current? Okay, so what we need to do here is we need to create an equation and then solve for the variables. For all of these questions where you're talking about distance, rate, and time, we actually want to use the idea that distance is equal to rate times time. We might use different equations like rate is equal to distance divided by time, or maybe distance is equal to time. Distance divided by rate is equal to time. So let's first try to see what key information do we have. So it's asking for what is the speed of the current? What is the speed of the current? So the question we're trying to answer is that we know that our speed is either equal to 32, and if you're going with the current is pushing you, so current, it would be plus c, right? We know one of the speeds, one of the rates, we could say rate 1 is equal to 32 plus c. This just means that if you're riding on a boat and you're riding with the current, you're going to go faster. Rate 2 is the idea that you're going against the current, so it's 32 minus c, because as you're going against the current, you're getting pushed backwards. We know that the total time, so time 1 is equal to t, right? However long that is, and time 2 is just the remainder of 10 hours minus t. 10 hours minus t. We know that the distance it takes is equal to 150 miles upstream and also downstream. So we can say the total distance is 150 plus 150. So now the problem here is how do we use all this information to figure out an equation to solve for the current, right? Okay, I gotta think about this one. So let's try to think about an equation which could solve for the current here. So 32 times t. Okay, so we could just try and set up some equations. We know that 150 is equal to 32 plus c. And so what I like to do is I like to just try and figure out some equations here. So I can see here that we could eliminate one of the variables just by making the time equal to each other. So I could solve for time here. I could solve for current. Let's see, I can divide everything by 32 minus C, and so see, this one would be negative 150 minus minus 10. So be plus 10 minus t equals 2. So I know that 10 minus 150 divided by 32 minus c is equal to 150, 32 plus c. So what I did is that in the second equation, I solved for t, and in the first equation, I also solved for t. So you can look at yours in a step back. Here. So for the first one, I saw that 150 equals 32 plus c. And what I see here, and the biggest problem here, is I have two variables. So what I want to do is I want to eliminate solving for two variables because I can't really solve it that way. So for my first equation, what I did is I just tried to isolate t, and I got t is equal to 150 divided by 32 plus c. Okay, so now I'm looking for c. So this is my first equation. My second equation, I have 150 is equal to 32 minus c times 10 minus t. And again, this is distance is equal to rate times time. And then I would divide both sides by 32 minus c. And I would get 10 minus t is equal to 150 divided by 32 minus c. And so I want to get t by itself, so then I would add t to both sides, and then I'm going to subtract 150 divided by 32 minus c, subtract 150, 32 minus c. The reason is I just want to get t by itself, and so here I get t is equal to 10 minus 150, 32 minus c. So now that I have two things equal to t, now I can solve. So now I go 150 divided by 32 plus c. I know that is equal to 10 minus 150, 32 minus c. And if this looks a little familiar, that's because now what I want to do is I want to get rid of all my denominators by multiplying everything by 32 minus c, 32 plus c, and then now I can solve. Now I can solve. Okay, so all of this is related to distance equals rate times time. Okay, everything is related to distance equals rate times time. Okay. So, sorry I probably didn't give you guys enough space. So you can see here that my denominators are 32 plus c and 32 minus c. So that means to get rid of my denominators, I'm going to multiply everything by 32 plus c, and I'm going to multiply everything by 32 minus c. Okay. So again, I have two denominators. So I'm going to multiply everything by 32 plus c and everything by 32 minus c. So then I would eliminate the first ones. I would get 150 times 32 minus c equals, and this one would be 10 times 32 minus c, 32 plus c, and this one would be minus 150, 32 plus c. So now I can just bust out my handy calculator. 150 times 32 is equal to 4,800 minus 150c is equal to, and here would be 32 squared times 10. This would be 10240. And since this is plus and minus the same thing, it would be minus 10c squared minus 4800 minus 150c. So what I want to do is I want to combine everything to one side if I can, if I have c's, but I can see here that I have negative 150c on both sides. So I'm going to cancel that out. I'm going to add 150c to both sides. And then I'm going to go ahead and move all of my numbers to the right hand side, and I'm going to add 10c squared to both sides. I'm also going to subtract 4800 from the left hand side and subtract 4800 from the right hand side. And I get 10c squared is equal to, and here would be 10240 minus 4800 minus 4800, and that would be 10240 minus 96, and that would equal, so 10c squared is equal to 640, and then I would divide both by 10. So c squared equals 64, square root both sides, c equals plus or minus 8. All right, well, all of that to figure out that the current is either 8 kilometers per hour or 8 miles per hour or negative 8 miles per hour. It doesn't make sense to have negative, so just the current is just 8 miles per hour. That's it.
Will this one be on the test?
Maybe.
I'm so confused on the last.
So what the first thing you want to do is you want to write down all the information you have. The second thing is that if you have two variables with the numbers that you set up, you want to solve for one of the variables. So in this case, we solve for t, so that we're only dealing with one variable. Okay. The next thing after that is now you just want to set them equal to each other, because now we have t equals. And then now we want to do the same. Now we're at the same step as before, where now you have a couple denominators. And so you want to get rid of your denominators by multiplying everything by the denominators. After that, you're going to solve for c, and then you're going to keep going. I know this one was a little harder because you have to think about it a little more. Usually they won't be this long, but again, like, it might just be with the equation that I set up. You can also create your own, which might make it a little shorter. Okay, we got one more problem left.
For the next one, can you do it for like today's worksheet?
Today's worksheet?
Yeah.
Okay. Problem set 5.
Like, can you do the last one?
Okay. Okay, so today the last one says, on a 130 kilometer trip, a car traveled at an average speed of 55 kilometers per hour. And then it reduced its speed to 40 kilometers for the remainder of the trip. The trip took 2.5 hours. How long did the car travel 40 kilometers? So the first thing you should do is to write down all the information that you have. So this one, we know for one fact, it is a total of 100 kilometers per trip. The distance is equal to 130 kilometers. We know one of the rates, so we're going to say rate 1 is it traveled 55 km per hour. And we know the rate 2 is equal to 40 kilometers per hour. we know the time it took in total is equal to 2.5 hours. So total time is equal to 2.5 hours. Okay, so for this one, it's a lot easier because we're given almost everything. And so we know that for this trip, we know distance is equal to rate times time. Right? Distance is equal to rate times time. So in this case, we know the distance, the total distance is 130 kilometers. We know that they traveled for about 55 kilometers. We don't know how long, so we're just going to call that t. And we know that they traveled for some time, right? So we know that they traveled for part of it for 55 kilometers per hour, plus they traveled for 40 kilometers for the remainder. So we know the total amount of time was equal to 2.5. And for however long they drove for the remainder of the time. So as an example, if I drove for 2 hours at 55 miles per hour, then, or kilometers, then this would be 2.5 minus 2 hours because the remainder of the time was spent driving 40 kilometers. So again, the distance is equal to both the rates, added together. And so here, we know that it would take us 55 plus, and this would be equal to 100 minus 40t. We would solve for t now, so you would minus 100 from both sides. You would get 30t is equal to 15t divided by 15 on both sides, and I get t is equal to 2. Okay, so the question here is how long did the car spend traveling 40 kilometers per hour? Here I see t is equal to 2, but if I look at my equation, I know that t represents the amount of time I spent driving 55 miles per hour, and so the total time is 2.5 minus 2, which is equal to 0.5 hours, which is equal to 30 minutes spent at 40 kilometers per hour. And that's it.